It says here, Elena's career began in metadata content for streaming managing cloud-hosted enterprise metadata portals, entitled Unleashing the Potential, How Automated Metadata Creation Can Improve Your Data Quality and Accessibility. Eleanor will explore the use of large language models, machine learning, and automation in data management. So I'll let Eleanor introduce more about her presentation.
Thank you. Thank you. Hi all. So first, a little bit about Astun. So Astun was founded in 2005 by Mike Sond, our managing director. So we are one of the national sponsors for today's event for this year. And Astun is the UK market leader for open source geospatial solutions. So that includes, web mapping, enterprise GIS, metadata, and data discoverability. And we have an inviolable track record in helping local government, charities, and commercial organizations enhance their service delivery. So I joined Astun about just under a year ago, and I deal with their data discoverability. And
sorry.
Oh,
it's all right. You can keep clicking.
Okay. So what is metadata? So my colleague Joe Cook actually covered this in a webinar. I've put a link to the YouTube presentation of that in my speaker notes if you get access to the slides. So the way I think of it is as like the labels on the cans in a supermarket, and that's actually what Dan taught me, and it stuck with me. So if you go to buy something in the supermarket and you have no labels whatsoever, then you might want to buy dog food, but you might end up with cat food or beer or who knows what you're gonna end up with. No, yes. Our own technical issues. Oh, there we go. So yeah, in simple terms, metadata is data about data. So another term that's quite popular these days is QFAIR. So what is QFAIR? Well, QFAIR is all about making your data high quality and findable and accessible, interoperable and reusable. And this is best achieved or mostly easily achieved if your metadata is also QFAIR and if you stick to like open standards and like formats where possible. So the letters, we have Q, which stands for quality. The hyphen is just a hyphen, means nothing. Findable, we have A for accessible, I for interoperable, and R for reusable. So why are we doing this project? So in Astun, we have a need to make it much easier for our clients to populate their metadata catalogs for like thousands of data sets at once. And
sorry, I'm so sorry to interrupt. Just check the mute.
Hello.
I think if you hold it a bit
closer. Is that better?
Everyone hear that? Is that okay?
Okay.
Sorry.
That's okay. That's fine. Thank you. So how are we doing this now? So we use Crawler, which is an open source plugin for Talent Open Studio. So what Crawler does, it looks for spatial data in file systems and databases, and it creates a metadata record for each data source it discovers, and a feature catalog for the spatial vector datasets. And what we do, we generate a spreadsheet with a row per record for data owners to complete. And I included a link to a previous presentation by Jo, where she discussed this in like way more technical detail than I'll do now. So if you want to see that, it's also in the speaker notes. So what are the fields that we need to create compliant metadata records? So there's a number of them. There's a whole bunch like the abstract and the bounding box, and like the date and contact details of who owns the data set. All sorts of things for like inspire, so inspire keywords, normal keywords, lineage, resolution, temporal extent, title, things like that. So as you can see, it's quite a big set of fields.
Hello. Hello. Hello.
This is your 3-minute interval call. If you could all return to your seats, that would be great. If you could start returning to your seats, that would be great. We've got a tight agenda with all the streaming and all of that. So. If you just bear with us a sec, we're just trying to move on to a faster Wi-Fi for the benefit of the streaming. So. Should we just leave it as is? Yeah, we'll just have to leave it as it is. Yeah. Okay. Cool. Yeah. So welcome back for the next session. Great talk earlier about the power of AI and ChatGPT. That all the speaker introductions were put together by taking all of the forms that the speakers filled out and putting them in ChatGPT and saying, write us a speaker introduction. So, and I then actually had to, I think it must have been trained on those American conferences where they all go in with whoops and cheers, because I had to get ChatGPT to tone it down a little bit. If I had to do it twice, and in fact I handed Elena's over to Sam to do the introduction, and he toned it down even further, so he's scribbling it out. So where's the fun in that? So with that in mind, it's my pleasure to introduce our next speaker, Petya Kangalova, representing the Humanitarian OpenStreetMap team, originally from Bulgaria and currently based in Bristol, UK. Petya serves as a tech collective facilitator for this remarkable organization. Petya's passion lies in the profound impact of open mapping and the use of technology as a catalyst for community support. And in her role, she strives to cultivate a dynamic collective of open tech contributors from all corners of the globe. How's this going? So that's all right? Yeah, okay, good. Good. So today, Petya will take us on a journey into the world of open geospatial technology, specifically focusing on its humanitarian applications. If you've ever been curious, I'm sure you have, about the individuals driving geospatial technologies for humanitarian purposes, this talk is for you. I'm only halfway through, but I think what I'll do, I'll hand over to Petya now to take it from here. I'm sure she can fill in any other gaps.
Good. I can't remember what I've written when I applied, but I guess it was long. Can you hear me okay? Yeah. Right. Hi, everyone. As I was introduced, my name is Petja Kangalova, and I work for the humanitarian OpenStreetMap team. I'm super excited to be here because you hear a bit more. We are an organization with 100 staff of over 40 countries, so very few here in the UK. We're all fully remote. As I said, my role, I've been for about a year and a half in the team, and my role is more on engaging. So engaging contributors to our open source software, running community events and facilitation, not coming from a computer science background, but I'm also very passionate about being able to communicate very technical things to users and the importance of bringing them into anything we do. So Humanitarian OpenStreetMap, HOT for short, is our team. We are a non-governmental organization, and I would say we sit a bit in the intersection of participatory mapping, tech, humanitarian response. So we define ourselves as a catalyst. As I said, international team dedicated to humanitarian action through community involvement and really focusing on open mapping. I'm sure you all know OpenStreetMap and you have all contributed. How many of you have contributed to OpenStreetMap? Great, and if you haven't, now is your chance to take a look and do that. So OpenStreetMap, as you know, over 20 years, the humanitarian OpenStreetMap team started very much with a clear need around 13 years ago in response to the earthquake in Haiti. So when the earthquake happened, at that time, the team was maybe 7 or 8 people and volunteers. And there was a lack of available data in Haiti in reaching people, in humanitarian respondents going in there. And that's where we started as a team. And that's where one of the tools you hear about, the Hot Tasking Manager, was also developed and is still probably one of the tools we use the most. What is our mission? Again, as a catalyst, we work, you hear more about the communities, local communities, and it's really about enabling them to use this data for decision making, and is something that's enabling them or improving their livelihoods. So that's really our key mission. A bit about what we do here. You see different areas. So we're not just focusing on tech, which I think is important. You hear more about the use cases of the open geospatial technologies that we run, but we support humanitarian response. You hear some examples of that. We play a big role in mobilizing contributors. By this, what I mean is mobilizing volunteers in mapping. So whether it's organizing mapathons, people who contribute to OpenStreetMap in the different OpenStreetMap communities, so around the globe in East, West Africa, and you see about the different regions. And in tech, we develop free and open source software, mainly focusing on collective mapping. You hear the different examples, capacity development. So there are different areas. I think tech is just one part of it, and it's enabling local communities in the regions we focus on. So this is where our staff is, mainly in our 4 priority regions. So that's the difference when people hear about OpenStreetMap, the humanitarian OpenStreetMap. We have 4 regional hubs, which you can see: Asia Pacific, Eastern, Southern Africa, North and Western Africa, Latin America, and the Caribbean. We grew from, as I said, in 2010, around 10 staff members to now 100 staff members, mainly based in those countries, in the regions where we focus, with their own individual programs of mapping, enabling contributions. And then I'm based in Bristol. We have a few staff members in our global team, which focuses on tech. So in tech, around 10 probably staff members, product owners, developers. We do rely a lot on volunteer contributions that I'll mention, and maybe I'll interest you in that. And then we have community and partnerships team. But I think what's really critical with this work and the context that we focus on is that most of our staff are based in the region, and we have around 94, which is quite a high number, priority countries where we work within those regions. Here is a photo. We're all, as I said, fully remote, so I'm happy to be here with an in-person event, but this is the once, I think, in a lifetime opportunity we had to meet in person, the whole organization in Kenya earlier in the year. And yeah, for me, it was very inspiring just hearing all the stories, and I would say the impact that people see of open map data and the tools we use mainly in those countries. So here I've added a QR code of like why we do that, why do we exist, like what is the impact of the work, like why do we enable this technologies and mobilize so many contributors. This is just from last year, and you can see a number of like people who mapped a number of different projects. If you look in more detail, you can see on the map the regions we work in and the specific like projects. I'll pick one example just to show you the kind of the impact of our work, which is in India, so engaging social enterprises. Some of our teams worked with social enterprises, so they worked with a aquaculture startup in India, with their main aim is to kind of support fishermen in, I think, increasing the fisheries yield. But what they were really lacking in that context is knowing where ponds are in the area. So they didn't have this data, they didn't have this information. So what we did was organize like a mapathon, so mobilizing contributors, around 400 contributors. And I think within 2 days, they managed to map like 22,000 ponds, I think, in that specific case. So that already had an impact. It's something that was a gap for people within that region. You can see different examples of hospitals in Senegal, like healthcare centers and others. So I think the topics, and when we think of mapping, I think it's important. It's not just buildings, but also we just had a discussion about like trees, like in the Amazon. So what are the topics of like enabling communities within that context? So the title of the topic is about collective intelligence, and you hear this word quite a bit, but I think within what we do as an organization is very key, and it's very critical, whether it's on contributors, whether it's developing the tech and developing the tools you hear about. I'm sure you're excited to hear more technical things. I think it's really, really important, and most of the tools that we built and we're still maintaining was really coming from like the people that we were working in. As I said, response to the earthquake in Haiti. Actually, more recently in Turkey as well, we had quite a lot of like organized contributors and mapping some of the areas there. But this is what we mean. I think that's quite core of like bringing the people and the communities we work with, developing the tech and collaborating with the kind of information and data. So the tech, what are the open geospatial tools? Maybe you've used or you've heard some of those. As we all here work in open source, and there's so many different, like when I joined, I was like, wow, there's so many different tools, whether it's for remote, for mobile mapping, for using the data. So what's different for our team, I would say, is that we focus on enabling what we mean by collective mapping. So multiple people being able to, especially in disaster response, I think that's also quite important to be able to do that much faster. And in collaboration with people on the ground. So there are different tools for like remote, but also field mapping. So here we are. Maybe you've used some of those, and we have developers and product owners on those. I might not be able to answer all the really detailed questions for specific tools, but I'll do my best. So one of the tools that's maintained within our team is Open Aerial Map. Open Aerial Map, as you can see here is the URL, you can check it out. It's for searching, sharing, and using open aerial imagery. You can also upload drone imagery. The most recent thing we did was work with a company to improve more the user interface, so you can more easily search for that imagery. I know specifically, like our team, very practical example, during the earthquake in Turkey, there was a lack of imagery, and I know they used Open Aerial Map in uploading some of the imagery and then linking it to the tasking manager, which is another one of our flagship tools. So the hot tasking manager is the tool, as I said, starting also with the response to the earthquake in Haiti. What it is a web-based application that you look at. There are different projects. I would say most projects in the tasking manager are within the countries that I just mentioned in the region. So you might have a project in India for a specific area. You look at satellite imageries, and that project, that area is divided into tasks. So that's when multiple people can map at the same time. So they look at satellite images and they map buildings, roads, and other areas. And we organize various what we call mapathons. Has anyone been part of a mapathon? Yeah, okay, there we go. So I'm sure there are activities, they happen all around the world. I think in the UK, there's a lot of like missing maps, if you've heard as well in London. But I think it's also that really brings people together, something that's like impactful. And also as a tool, there isn't another one that allows you for multiple people at the same time to not duplicate effort, but choose it. You can do it in your own time. So I encourage you, you can take a look and choose a project and map. You don't have to wait for a mapathon to do that. Oh, and the end, but it's not, sorry. Okay, that was me. Okay, so I talked about imagery. Then we have remote applications for coordinated mapping. And this one is one that we're currently developing. So there's a lot of, if you're interested, I'll talk about how you can contribute and join us in this. So there are loads of mobile applications. I'm sure maybe you've used Organic Maps, Street Complete, OSM and others, where you can use your mobile phone, go in the field and add data, map data. What we identified as a problem and really working with people in the regions we work is that there wasn't a tool that allowed for organized field mapping. So you have 20 people, let's say going around Bristol as an example, and you don't duplicate. You can choose, okay, I'm mapping this area, others are mapping a different one. So that started as a, as a specific kind of problem identified. And it uses Open Data Kit, a mobile application currently in development. And that's where actually I'm really happy that we had quite a few volunteers supporting us in the development of the tool. I'm really excited about it because I think it's yet another tool that there was a clear gap for coordinated field mapping. And there are a lot of field activities in the regions where we work. It's currently in deployment, so a lot more to happen on this one. If you're interested, I can tell you a bit more. And then, this is not loading, but we have FAIR. So we also have a project and we have a small team that we all talk about AI at the moment. So what FAIR stands for is a local and open AI-assisted mapping tool. The F is for free and open source software, AI, artificial intelligence, and then the R is for resilience and responsibility for the communities. Maybe you've used different AI models. There's one called Rapid that's used often for mapping. What it means is you can see the prediction for already for the buildings, and you can, verify and say that's correct or fix it. The two, I would say, key problems specifically to our context with this model that's currently being developed is around the biases. So a lot of models are trained, without including a good example. One of my colleagues uses is, for instance, this at the top right. You have a circular building. Let's say in Mongolia, buildings might not be the same as here or in different contexts. So that's really important for us. And that's what we're doing. We're training those models by using local knowledge. So in the regions, in different examples I mentioned, and then also including, so we say, human in the loop. So having the feedback of, okay, this was incorrect, like why, like fixing it. If you're interested, I can connect you with like our leads on this, but I think we feel also quite passionate about this, about, AI is really important. It started as a project. We did a pilot where I think in Uganda and Tanzania, we showed that there is efficiency in using AI in mapping. I think it was kind of doubled the number of buildings mapped. So that's when we started this concept. But I think the process of it, the really important bit is including people. I think I'm okay with time. And then last, as I said, so different tools for mapping, collective mapping. And then we also have a tool that we maintain, which is called Export Tool. So a lot of data goes into OpenStreetMap. How do you export it and use it? Some of this tool is linked to the Humanitarian Data Exchange, if you've heard, which is a big platform for like used by humanitarian organizations. And again, I think one of the most downloaded data sets during the Turkey and Syria earthquake was actually using export tool. Right, last 3 minutes on how you can get involved. I'm sure we have a good audience of, people who contribute to open source and get involved. I always say this, that there are different ways to get involved in open source. And I use myself as an example because I don't come from a computer science background, but I think there's loads of ways in which, in what we do, if you're interested, you can get involved. So advocating, educating for the power of open source. I think an open mapping, I've been to quite a few open source conferences where people don't know about open mapping or are not included. So that's something I think is really important. Testing and improving user experience. So including people who are using the tools on the tasking manager, for instance, something that we run is like a monthly meetup, people from around the world join and they test. When we have something on staging, for instance, they test it. So we actually don't push and add new features without including. And that's a lot of volunteers joining us, sharing feedback. Documentation, I'm sure we all know how important that is and how little time we spend on it. So if anyone's interested in contributing, I mentored an intern as part of an outreach program. Maybe you've heard, it's about like open source, like diversity in open source. If you haven't, I would encourage you. I think it's a great initiative. And we had an intern really helping us with the documentation on FAIR and field mapping tasking manager. Translation, very important. We work with different languages. And of course, GitHub. I feel like this audience would know quite a bit about GitHub, so I might skip this bit. But yeah, this is like the QR code if you want to already check our repos about the products I just talked about. Different ways, look at the contribution guidance, the pinned repositories, and you can choose something of interest. And that's where I'll end. I would, in open source, we all collaborate, and I think there are people with different input. If you're interested in hearing more, on GitHub, I also facilitate, we have different working groups. So we have the Hot Tech and Innovation Working Group. It started this year. It's really a space to share different ideas, to collaborate. Sometimes there are people from different regions that might have the same experience. We did a webinar on perspectives on AI and open mapping. If you're interested, join us. And yeah, my email, and come and chat to me. I think I'll end here, but thank you all. Any questions?
Thanks, Petya. That was a really interesting talk. Any questions from the audience? I thought you would have one.
Hi, Petya. I mean, first of all, I work with Map Action, so OSM and the stuff that Hot does is probably our most important single resource. So it's been incredibly useful over the years. But one question I've got is just on the metrics. Do you have data on what's done, what's not done, and how do you, and how reliable is that, and at what level of granularity, if you have it, at what level of granularity do you have it? Can you look at an area and say, well, there's not much data here, but here it's really good and it's reliable. It's really about confidence and reliability.
It's definitely something. So in terms of metrics, I didn't share a lot, but it's something that we look at, not just contributors, but areas mapped. I think your question is the metrics before, which areas do we target? And I know some of our colleagues are looking into that. There's something I think currently in development called DMAP to think about prioritization of where do we go and map. Was that your question of more before you go into mapping, which areas are less mapped?
I guess it's being able to look at an area and have an idea of what sort of level of coverage there is, i.e. how confident that we can be if we look at an area and say, obviously there's a buildings data set there, but is it 20% of all the buildings or is it 90% of all the buildings?
Yeah. It's currently, I won't be able to specifically tell you, but that's part of, I think in the tasking manager, there's a part on data quality of looking in the specific areas. And that's something actually now we're working a bit more to be able to present that information because I don't think it's easily accessible. But yeah, very relevant.
Anyone else? Any other questions? Actually, I might have a question for Ant. From the map action perspective, what does it mean for you in practice having this sort of data out in the field? I mean, how fundamental is it to all the stuff that you do?
Yeah, I mean, it's one of the first, if not the first, data set that we'll download. I mean, without it, we're scrabbling about, trying to contact the National Mapping Agency, getting hold of data. So we use it always. We use it. I was doing training a couple of weeks ago, and we use it in training. So, and I think one of the interesting things that in training is that a lot of the people we're training haven't come across it before. So, you know, we're trying to raise awareness of it, trying to encourage people to get involved in mapping their local areas as well. So yeah, I mean, it's absolutely, as I say, from the Haiti earthquake onwards, it's absolutely fundamental to what we do.
Thanks very much. That was really, really interesting. So I'm not a huge user of OpenStreetMap for my sins, but mainly because of what I do. But I've been hearing a lot recently about sort of some of the big tech companies like Meta and Google kind of flooding OpenStreetMap with huge amounts of data, a lot of it AI generated. How does an organization like yours, which is relatively small, who I presume are reliant on really high quality data, how do you deal with that enormous amount of information that you must have now flooding in?
Yeah, that's a big question. I think we do have engagement. I think there's one initiative that maybe people in OpenStreetMap community have heard, which is Overture, which is kind of the big tech and kind of adding data. I think what we do is ensure like what's our added value. And I think, again, with humanitarian OpenStreetMap, really thinking about the regions that we work in and kind of addressing like their needs. I think the simple answer is like we do engage also with the big tech in a way, like we have not like direct partnerships, but there are also teams within those like Meta who are using OpenStreetMap. So it's kind of, I think in a way, finding that balance of like where, you know, what we stand for and our mission is aligned. But I do think at the moment there is a lot of movement in that scene, and yeah, and I think it's something we like kind of in the director and other levels like monitoring and engaging as well.
Thank you. No, it's reassuring to hear that they are at least engaging, so that's great.
Yeah.
Sorry.
I'm interested in your local and open AI assisted mapping tool. I just wonder where you're hoping to get to with it, and what sort of level of maturity you would say it's at the moment.
So it's, I think they define it as alpha stage. So we don't already like share the model. So I think we're still at a kind of testing phase. Very good question of where we aim to be. I think it is training the models to then be able to use that in tools like the tasking manager, where people use it for their local projects and be able to use that predictions that's more localized for that specific area. That's maybe more kind of short to medium term.
Okay.
Any others?
Mine's more of a comment really than a question, which is that the kind of missing maps things are really fun to get involved in. So definitely recommend people going to check that out. Like if you work for a big corporation, then you probably get a couple of days where you can volunteer for some sort of charitable organization. So maybe think about checking out Humanitarian OpenStreetMap for doing that. Yeah, and if you know there is a disaster around the world, jumping on the tasking manager or jumping on one of the Humanitarian OpenStreetMap systems and digitizing some stuff, helping them identify, you know, things in satellite imagery is actually pretty rewarding. So, cheers.
Thank you.
Awesome, thanks. Well, if there are no more questions, we just show our appreciation for Petra again. Thanks. Awesome. Are you able to tee up next? Yeah. Great. So we're just going to get the slides up for the next talk from Mark and Neil. So back to the ChatGPT intros. Ladies and gentlemen, we're thrilled to introduce our speakers for this session. Come on down. Mark Gibbons and Neil Justice, representing the Centre for Sustainable Energy. Mark and Neil are instrumental members of the team, and today they will unveil an exciting project titled Solar Potential Modelling for Household and Community Solar. Mark and Neil will immerse us in the world of spatial modelling. They will introduce us to the Solar Wizard, a remarkable household and community solar assessment calculator designed to provide quick, accurate, and independent predictions about the viability of solar PV. How's that? Is that all right? It's scary, isn't it? I mean, it's based on the information you put in for your talk. So awesome. Let me hand over to you.
Thank you. Cool. Yeah, cool. Right. Cool. Thanks. I'll start the time. Okay. Yeah, I'll firstly start by saying that when I practiced this last night, I overran every time, so I'm probably going to rush through some slides. So apologies in advance. So yeah, I'm Mark. This is Neil. We're both at the Centre for Sustainable Energy, and yeah, we're going to talk about our tool for modelling rooftop solar potential of buildings, which we've christened as Solar Wizard. Okay, so yeah, that's us. Okay, so a quick overview of the talk. Yeah, I'm going to briefly introduce CSE, and then I'm going to kind of give a bit of a background to the application itself and show you kind of what it looks like. And then Neil's going to dive into the more technical aspects of the solar modeling program. Where should I be pointing this? I know. I can talk a little bit about CSE while we're going to the next slide. So, oh no. Seems to be that when it's sharing the screen on Jitsi, it really doesn't like that's unfortunate. Anyway, I'll carry on. Yeah, so CSE, we're an independent national charity based here in Bristol. We're about 100 strong, and our mission is generally to fight the climate crisis while trying to ensure that nobody gets left behind in the net zero transition. As an idea of the kind of work that we do, we've got various teams within CSE, and we do a range of things from offering home energy advice, advice about home retrofit. We have a communities team who do bits of outreach and who run our youth program called Bright Green Future, which is for sort of, I think, 14 to 17-year-olds. And yeah, finally, we've got a research team, which is what myself and Neil and indeed Al Graham here are part of. And we do a variety of sort of software modeling consultancy work, as well as some social and policy research. So I'll quickly go down. So examples of our past work very quickly, various energy resource assessments, net zero action plans for local councils, local area energy planning method. And on the software side, we've developed various bits of tools and bits of modeling for people, including the Thermos tool, which is a tool for optimizing and planning district heating networks. The London heat map, which we developed for the GLA, which is sort of a one-stop shop for all things decentralized energy and heat in London. And finally, this is the impact tool, which is a carbon footprint calculator, but it's not for people, it's for whole areas. Okay, so a bit of a background to the project itself. It was part of the SBRI's Open Digital Solutions for Net Zero Innovation Competition. So this is funded by Innovate UK. And the kind of aim of the competition, like it says here, is to develop open solutions to accelerate decarbonisation of energy in the UK. So yeah, our submission to this basically focused all around solar rooftop potential. So effectively trying to find out if you've got a building which presumably has a roof, and you put solar panels up on that roof, how much energy can you expect to generate? And really, we wanted to create a comprehensive map of this data for the whole country, and to put it in the hands of people who might want to put up panels on their buildings. So that could be individual people, or it could be community energy groups looking to develop really large solar arrays on big buildings. And so, yeah, the funding allowed us to build on an existing model that we've been developing, and it also enabled us to create a sort of a mapping interface for it, which I'll show you in the next few slides. Yeah. So yeah, throughout the course of the project, we had a few workshops with various potential stakeholders, and we kind of concluded that that there would be two main kind of users of this sort of application. One of which would be people who are really only interested in one building, typically their own home, and the second who would be people who are generally interested in a much broader view. So that would be people like local authorities who wanted to kind of survey their whole region, or local community energy groups. So that kind of led us to develop effectively two applications. The first of which being the kind of individual version, and this shows you all of these things, and I'll show you a screenshot of this in a minute. And yeah, one thing to note here was a partial motivation for developing the single building version, that was that we were using ordnance survey data there, and therefore being able to have a version that just showed a single building rather than a whole map of data allowed us to kind of minimize the royalties that we'd have to pay to OS for that. So that was helpful. So here's a screenshot of what it looks like. I'll kind of hasten to add that it's still sort of in development at the moment, but we're sort of nearing the kind of final version. So you will just type in your address or postcode into a search box, and it will bring up this page for your house. And we give you a kind of score out of 5, and also give you these bits of information here. So the total energy you can expect to generate per year, how much this will save you off your energy bill, what you can expect to pay for the installation of these panels, and an expected payback period. And crucially, from our point of view, the carbon savings that you can expect from a given installation. So a bit further down as well, there's a bit more detail here, and our first piece of geospatial data there, which is the building outline and an indicative placement of the panels there. But we do hasten to sort of add that if you go off and talk to an installer, they may well give you something that looks a little bit different from the array that we show. I'll quickly move on to the next bit, which is a bit more interesting, I think. Yeah, so like I say, at the top, we give these figures for kind of an average installation for what we kind of assume to be average energy use. The reality is quite different though, depending on your individual usage patterns. So, and this will have a big effect on how economically viable this is for you. Yeah, the real reason for this is that if you generate a kilowatt hour of electricity from your panels, it will go into your home appliances, and it will run your fridge or run your microwave or whatever, and whatever's left over will get exported to the grid. So if you use up a kilowatt hour of electricity in your home, then you'll be offsetting about 30p or so from your energy bill, because the price of electricity is pretty high. If you were to export that to the grid, you'd probably get only 5-10p at best, because a few years ago the government scrapped the feed-in tariff, so you don't get a lot of money for the any electricity you export to the grid. So generally speaking, it's likely to be you're likely to be economically better off if you're somebody who tends to use a lot of energy while the sun is shining. That might be because you've got an electric vehicle and you're charging it up. But of course, you can change your energy usage patterns by, I don't know, yeah, doing your laundry in the middle of the day or something like that. So yeah, clicking the wrong button. The second incarnation of the tool is basically a web map, and I'll touch on our kind of business model a little bit here. So part of the funding requirements was that we build a sustainable business model for this product, and ultimately we decided that for various reasons it would make sense to market it towards local authorities, and the reasons for this are that, well, firstly, we know there's kind of a market among local authorities for this kind of data. They want to be able to look at not only their own building stock, but also at the general sort of housing stock, and maybe target policies for certain areas, stuff like that. And secondly, quite fortuitously for us, local authorities have PSGAs, public sector geospatial agreements, which allow us to basically open up that ordnance survey data not only to the local authorities themselves, but to individuals and community groups in that area. So that is yeah, very, very helpful for us. And yeah, luckily we have we've got sort of 2 orders on the book that we're working towards going live on. So I'd show you kind of mock-up of what it looks like. It's just a simple web map, and all the buildings there are coloured in on this sort of 1 to 5 scale, based on the yield of the panel installation, which is kind of like the bang for your buck value. I'll move on from here. Yeah, in the next screenshot as well, this is kind of an example of a bit of the additional functionality that you get as a local authority user. So you have the ability to draw out an area on the map and get a bit of more detailed analysis of this area. So you kind of get a table here which you can sort, and you can click on the individual buildings on the table and get more information about each one. But also you can run financial modeling on this area, so you can do things like work out, the total cost, or if you were to put panels on all of these buildings, what would be the total cost, the return on investment, and stuff like that. Yes. Yeah. Finally, I'll just touch on some of the open source software that we made use of in putting together the application. So a fairly standard stack of things. I think we're enormously grateful, of course, to all these people. Yeah, I don't know if there's much more to say. I think probably most of you will have heard of most, if not all, of these things. Maybe not Tangram, but that's a kind of WebGL rendering engine, which allowed us to render the large number of buildings in the web map. So yeah, that's where I'll stop and hand over to Neil, who will talk about the modeling aspects.
Thanks, Mark. Can everyone hear me? Cool. Right. How does this thing work? Yeah, so I'm going to talk a bit about the model. Sorry, to mouth like that. Oh, that sounds better. Yeah, thanks. So yeah, the model is open source. Okay, you can get it there. We've had a solar rooftop potential model at CSE for maybe 5 or 6 years. I started working on the current one 3 or 4 years ago. We did a lot more work on it with the Solar Wizard funding last year, and now we're currently working on and off on version 2 of the model. So our goal is to be able to use it to model all the rooftops in England, Scotland, and Wales. It could be used anywhere else, though, if you've got the right data, you know. So yeah. So this is what the model does. Basically, we have as inputs a LiDAR DSM at 1-2 meter resolution, which is basically a kind of height map of the whole country, which you can see here. And we also have these building footprint polygons. As Mark mentioned, we're using Ordnance Survey ones, which aren't open. But you could use OpenStreetMap ones or model ones. They would work fine too. We use Ordnance Survey because the coverage is better, unfortunately. And it's easier to link up to an address from a building. So yeah, given those inputs and those outputs, what can we do? Because we want to get this kind of rooftop installation size and expected monthly yield and annual yield. So this is a rough overview of the model, very high level. We load some data in. We check for any misalignments between the LiDAR and the building polygons, which could be due to outdated LiDAR, because we're using a composite DSM from many different years. It could just be for many reasons. So then we try and work out the shape of the roof. We try and draw a nice polygon around the shape of the roof we think we've discovered, do some solar potential mapping, and then finally tie it all together and hand it over to Mark. So I'm just going to briefly talk about PV maps. It's not something we made, so I'm not going to go into it much. It's an open source piece of software that's not currently maintained. So if anyone wants to go and maintain it, that would be great. You might have heard of PVGIS, which is kind of an online solar potential thing. This is their offline raster equivalent. So basically, you give it a load of rasters and it puts out another one. You give it an elevation raster, a slope raster, an aspect, which is kind of the compass orientation raster, a load that represent the kind of the horizon profile of each pixel, and it spits out another raster which represents the kind of the solar potential of a 1 kilowatt PV installation centered on that pixel. So it's a fairly good tool, I think. It's fairly sophisticated. It has things in to kind of factor in speed of wind and various types of losses due to different types of light. Yeah, but so you could have a fairly simple model just using this. You could say, take the outputs of PV maps and add up all the values from all the pixels that intersect each building. So that's a building polygon. And then multiply by some factor that says what the real kilowatt per meter squared number is. But you can't really put a panel on every square meter of a roof. That's not really how roofs work. So what we wanted to do was find where the bits of roof are that you could actually put panels on. So for that, we need some roof plane detection. This is the bit I was going to talk about more in more detail if there's time. How are we doing for time? Good, yeah, cool. So yeah, given that what we have is a building footprint and a height map, how can we work out what shape the roof is? So we model a roof as a set of different planes and the points that lie on those planes. And this is a kind of a fairly well-studied area in computer science. There's a few papers on it out there. So our initial approach used a modified version of an algorithm called RANSAC, which is based on this paper, Darshak Kurdi, 2008. No AI here, sorry, it's just stats. I think it's always good to have things in your toolbox other than AI. I'm going to have to go into RANSAC a little bit more. Sorry, it's going to get technical. I'll try and keep it simple though. So it's a linear regression model. So what it's trying to do is fit a line to some points or fit a plane to some 3D points in our case. So, this is a building. It's got a roof going in that direction towards the top right, and it's got another roof pointing towards the bottom left. So what we're trying to do is find basically two rectangles, one here and one here, one pointing down to the bottom left, one pointing towards the top right. So in version 1, we basically followed that paper that I mentioned, but we tended to find that in a row of terraced houses, this is a small terraced house in Bristol, you'd get a row of terraces like this, and it would be missing. Sometimes it would get both roofs, sometimes it would get one, and sometimes it would get none. And these are all things that to a human eye look very similar. So, people would look at the map, they'd be unhappy. Why is my roof not showing up? My neighbor's roof is there. So we went back to look at this again. So RANSAC stands for Random Sample Consensus, if you can call that standing for. It's a bit of a stretch, I think, as an acronym, but so the clue's in the name there. It's got a random component. So what it does is tries to pick 3 random points to start with. So you can see here the yellow dots are the 3 that it might have picked to start with. It then tries to fit a plane just to those 3 points. It looks to see which other points in the data also fit that plane or are near enough. And then if that's the best plane it's found so far, it keeps that. And then it just goes round and round that loop for as many trials as you want. Could be a few thousand often. So the problem is, this is a very small building, and even this has 46 meter squared pixels intersecting it. So that's over 15,000 different potential samples, and a lot of them are really bad. So, this one, for example, cuts across all the roofs on this building. It's going to give you a weird plane that kind of is angled across things. This one's good, but there aren't really actually that many good initial samples in there. You have to not only get them in the right half of the building, you have to get them well distributed across the roof too. If they're all in a line here, that's not going to work. If they're all bunched down in the corner here, it's going to fit something a bit off. So yeah, that's the problem. And basically it's because RANSAC is designed to deal with any sort of data. It's not about roofs, So we went and thought a bit, and basically it's something that we know about roofs we can use to choose better starting samples. And basically, yes, there is. So we tried quite a lot of different things. The thing that we think works best is basically using an aspect raster, which is a compass orientation raster generated from the elevation map, which you can do by taking the X and Y gradients and doing some trigonometry, waving my hand. Yeah, so we take that and then do some segmentation on it to get these large groups with some outliers in the middle. And then each of those groups becomes the basis for the sample. You can see we've got a really nice sample that covers this bit of roof very well, and it finds a roof. So the only thing left to do after that is draw some nice shapes around those, which is a lot harder than it sounds actually. Still a work in progress. Yeah. Tooling wise, the model is in Python, uses a lot of the standard sort of scientific Python libraries, PostGIS for state storage, PV maps, which I mentioned, which is built on Grass, GIS, a bit of GDAL for loading things in, and QGIS for debugging and making those pictures. That's it. I should say, if you think that looks like interesting work, we are hiring software developers, so come talk to us. I think that's it.
Brilliant. Thanks, Mark and Neil. We've got about 5 minutes for questions. So.
Thank you. That was fascinating. I was interested in how long it takes the model to run and how you do that in the context of the web map. Do you pre-run the model for all the buildings in an area and then display it, or are things generated on the fly when you go to new areas and so on?
Yeah, good question. We pre-run the whole model for the whole country. Which, the old version took about 30 days on our server, which has got 200 cores. Most of that is ransack. So the new, and because the more trials you have, the longer it takes. And so the new thing's actually a lot quicker. We haven't run it yet, but I'm hoping it's going to be on the order of a week or so rather than months.
And so for that, you just grab all the LiDAR data and so on for the whole country and run it in tiles or in chunks? Yeah. Great, thank you very much.
Any other questions?
When you're running it for larger areas and looking at the kind of solar potential, do you do anything about figuring out whether there are already solar panels on any of the roofs?
We do have a data set. It's not great. It's not got great coverage. It was crowdsourced, I think, and it's good in some places and not so much in others. We don't do anything clever with the LiDAR, like trying to work out what color the pixel is or anything. So it is one of the shortcomings of the model, is it will try and put panels on top of panels or on top of copper roofs and conservatories and things. So, yeah.
Do you look at shadowing and that sort of stuff as well? Does that come straight from the DEMS or?
Yeah, so one of the inputs to PV maps is this set of horizon rasters, which you can work out with Grass. Grass has a module for this, and it basically does some ray tracing on the rasters. And we do kind of 36 directions, so kind of every 10 degrees around the compass.
Hi, less of a geo question, but have you considered, or do you take the potential of energy storage into account in any of the calculations?
Yeah, not at the moment. That is a very good point, and I think in some of the conversations that we had with potential users, they did point that out. But we basically didn't get, we sort of ran out of budget before we could implement it. So yeah.
Yeah, I'm interested in the underlying data for solar and wind. Do you get that from the Met Office or where?
So that comes from the people who made PV maps and make PVJS. They make public these rasters that cover the whole world. Actually, I think they're kind of 500-meter cells.
Okay, thanks.
Is this all done on CPU, or is it using any GPU acceleration?
Yeah, it's all CPU.
Right. I might be able to help if you want to reduce a week down to days.
Oh, we should have a chat.
Yeah, definitely. Yeah.
Sorry, I'm really interesting talk. Just wondering about the sun data. Is there any indication that any climate change might make things cloudier or sunnier or affect things going forwards? Or is that a stupid question and really hard to work out?
I imagine it will. I mean, the data we have, I think they do update it every so often. I think it only covers the last 5 years or so to try and keep it relevant to making predictions. So we'd have to kind of look at the last load we got from them and then the next load and see what the difference was, but we haven't done anything like that.
One last question, and then I think we'll move on.
Thanks. Yeah, really interesting that. Have you considered going international with this model and looking at other countries where you've got, I guess, different azimuths and aspect ratios for the sun and things like that?
So PV Maps works worldwide. It's just a matter of data, really. We have data for the UK, and we generally work in the UK with the projects we work on. I think the model would work worldwide. I'd have to check. I'd probably have to do some stuff to the CRS I use in various places, but yeah.
Yeah, it's worth noting as well that I think there are a few countries where they've already got existing things. Like I think in Switzerland they've got a thing called Cadastre Solaire, something like that, which does a similar thing. So yeah, it has. There are a few places where they do it.
Fantastic. Thank you again, Mark and Neil. That was a really great talk, and thanks for all the questions as well. Thanks also, all the speakers doing a great job at sticking to schedule, which makes the whole organisation of it a lot easier and better for streaming as well. So next up we've got Rob Burgess from Inesis. Have I got that? Pronounce that right? Who specialise in offshore energy consulting, catering to a diverse portfolio of oil, gas and renewable projects. And this is a lightning talk, so we've got 2 lightning talks now, a little bit shorter, and about utilising Phos4G tooling for offshore platform electrification, where Rob will take us through a compelling case study that showcases the application of Phos4G tools in planning an offshore platform electrification energy project. I'll hand over to you, Rob. Thanks.
Sorry, the slides were nearly there.
If you want me to fill, I've got the rest of the page.
Yeah, you can do it. Yeah, the clicker's not going between it. I think you have to just scroll down and.
What, the thing?
Yeah.
Oh, right, okay.
We'll give it a test.
I'll spare you the fill.
That's all good. Yeah, that's cool. Yeah, I'll do. Yeah, it doesn't fill the thing. Yeah, that's all good.
Is this working? Yeah, cool. Hi, everyone. Yep. So today I'm going to be talking about Phos4G tooling and how we've used it on a recent offshore platform electrification project. So just to give you a very quick intro, this project is located in the North Sea. It's about 250 kilometers off the east coast of Scotland. And yeah, it aims to reduce the greenhouse gas emissions or the carbon intensity of a certain number of platforms in the North Sea. So obviously, these platforms, they're extracting oil and gas, but they're also using hydrocarbons to actually power the onboard facilities on the platforms. So one of the kind of options they're looking at is to lay a subsea cable from a landfall location, which you see up there, out to a hub, which is the white dot in the middle of the sea there, and then linking that up to some platforms, which are the four red dots there. So yeah, whenever you lay a cable, you have to trench it or bury it into the seabed. And this is to basically protect it from things like dragged anchors or like equipment being dragged along the seabed or currents, scour, that kind of thing. So in order to do that trenching, you need to know a bit about the shallow seabed geology, because depending on that geology, it'll affect how difficult or easy it is to bury the cable in the first place. Yeah, so our aim for the project was for a section of the route, which is that smaller red section there in the map, was to analyze some recently acquired geophysical data, and yeah, to get a better understanding of that shallow seabed geology, yeah, along the route, and to present that in both sort of a map form as well as produce some cross sections along the route. And then yeah, we're going to use some phosphorid tooling along the way, so a bit of raster surface generation, some Python data viz, and also some an atlas via QGIS as well. So yeah, I'll just dive straight into it. So in terms of the raster surface generation, a survey vessel would have initially sailed down the red line there, basically collecting data in like a 300-meter corridor either side of that red line. And that data would have been processed. And from that, you can derive various different things, as shown by this diagram. Hopefully you can see it in the top left. So you can derive things like the seabed, as well as any other kind of horizons that exist beneath the seabed. So this could be like other geological units, things with different geological kind of characteristics. So that data is processed and sent over to us in like an XYZ format, which is simply like easting, northing, and a depth value. And then you can use some tools like GMT and GDAL to like process that into a raster, which is this thing in the bottom left here. So this is just a snapshot of some bathymetry, which is like the seabed, basically. There would have been corresponding rasters for the other horizons. So effectively we had like 5 or 6 different surfaces that represented the seabed down to like the deepest kind of horizons there. Yeah, so once we'd actually generated those rasters, you could then actually move on to kind of generating the cross sections. So to do that, we first had to generate some points along the proposed cable route and basically sample the points with the rasters to extract values. And we also divided the route into 5 sections. This was basically to like, form the extents of each of the figures that you'll see later. Yeah, and the reason I'm mentioning this now is just because like the extents of the figures had to match the extents of the cross sections. So effectively, we kind of divided the points up between, amongst each of those polygons there. Yeah, we then exported the data from the sampled points there as CSV, which you probably can't see. But in the top right there, it's just showing like the depths of the seabed, as well as the depths of all the other horizons that exist beneath the seabed. So as you go further to the right of the spreadsheet, the depths become deeper. The KP column there, which is the second column in the spreadsheet, that's simply like the kilometers along the cable route, and that forms the x-axis of the cross sections that you see there. So yeah, we used the CSV within Anaconda or JupyterLab to come up with a script that used a Python library called bokeh, which is quite good for creating all kinds of visualizations and graphs and interactive graphs and things. So rather than actually show the script, which probably isn't really good for this setting, I've just done a very simplified diagram whereby the script imported the CSV as a data frame. We then extracted a unique list of figure names, which corresponded to those five polygons you see up there. And then once we had the unique listing, we could filter the data frame and then loop through that. So you could set up the figure, run some plotting functions, so it'll plot up the lines and also the areas beneath those for each of the horizons. Add the axes and the legend, and then export that as an SVG as the thing you see there. And then it would just loop back through to the next item in the list until eventually it generated the five cross sections for those polygons there. So once we generated the cross sections, we could move on to some mapping. So we used some atlas mapping within QGIS, which was just very useful for automating map production along the cable route. It's just much easier because you don't have to like make each map individually. You can export everything in one go. Again, I keep showing these polygons, which are not very interesting, but the polygons here are the coverage layer, which basically is controlling the atlas. and the attribute table there is just pointing to different elements on the map that it controls. So you've got things like the title is controlled by that KP label, not that you can read that from there. You've got the rotation and scale values that control like how zoomed in or out or rotated the map is. And then you also have like the graph file name there. So that will switch in and out the correct, cross-section for each of those. And then, in terms of the outputs, so these are kind of what it looks like. So you've got like two main elements. You've got like the map at the top there, which is the cable route. The numbers there are like the KPs. They're just kilometer markers along the cable route. You've got some bathymetry, various other kind of various other layers there. And then underneath that, you've got the cross section. So the cross section matches what is shown in the map, if you see what I mean. So it's kind of the same extent, the same data. And then effectively, you can just scroll through and it exports an alignment sheet for each one of those 5 polygons that we saw earlier, just like putting in the data as and when you need it for each one of these. So yeah, it was just a very useful exercise for like if we have to repeat this at another point or like do it for a longer section of the route, or indeed rerun it for like new data sets should they become available. We can relatively easily do that. So that's pretty much it. I've just some conclusions here. This is a very quick overview of some phospher-G tooling in support of an offshore platform electrification project. We've used some GDAL and GMT to generate rasters. We used a bit of Python to generate the cross sections, and we've also used an atlas to automate the map production. And yeah, as I just said, it's an approach that is reproducible over different sections of the route, or for longer sections of the route, or yeah, whatever. So yeah, that is me, I think. Cheers, guys.
Great. Thanks, Rob. We've got a couple of minutes, 5 minutes for questions.
Yeah, it's really a comment and a question. Just the comment, props to Rob's put up GMT. If you've never come across GMT, it's this awesome command line program. Most people may have heard of GDAL. Got a lot of respect for GDAL. GMT is like this awesome raster array-based command line tool. So props for using that. Also disclaimer, I used to do a very similar job to what Rob did. And I used to have to produce these maps by hand that Rob just produced. Any idea how much time you've saved? You produce consultancy reports with all that mapping output, right?
Yeah.
How much time, now it's automated, how much time are you saving?
It definitely saves you a lot of time. I guess initially there's a bit more kind of time spent setting up the template. But like once you've set up the template and you've got everything working, it's much easier to then like, keep rerunning it if you need to, do it for a different area along the route, or if new data comes in, something like that. So yeah, it definitely saves time. And like if you have to use it on projects, subsequent projects and things, it's like, it's very similar.
Any more questions? No. Nope. One more.
Thanks. That was really fascinating. I was just wondering, do you? So we saw that you're obtaining depths of the horizons there. Are you obtaining any information about the lithology and the makeup of the the bedrock and the geology?
So typically when that data is collected, it's analyzed by like geophysicists, either on the boat or back on shore. And so when they're analyzing that, you can tell like, or they can tell, I can't, what the geology is of each of those horizons. So they'll be able to say like this is mostly clay, or this is sandy, or this is gravelly, or whatever. So those horizons will have like the kind of geological characteristics predetermined by those guys.
Okay, thanks.
Any others? No. Brilliant. Thank you, Rob. No worries. Thanks again. Cool. So last lightning talk before we break for lunch. So this is Javier Garcia Lopez. I hope I pronounced that okay. Javier from 4Earth Intelligence. This is lightning talk titled Satellite-Derived Marine Habitat Mapping, in which Javier will immerse us in the realm of environmental impact assessment, specifically focusing on habitat mapping through satellite-derived data. This is a non-invasive technique that plays a pivotal role in identifying fragile habitats and a crucial component of environmental impact assessments. Over to you, Javier.
Thank you very much. Hi, everyone. I will try to keep it short so we can go for lunch. Yeah, so I wanted to show how we extract, we map marine habitat using free open software. And yeah, basically, well, we are going to check all these steps. Basically, first of all, I'm Javier Garcia, project manager at 4EI. We are experts in Earth observation, GIS, and remote sensing analytics. We not only map or produce, environmental maps or habitat mapping, but also we developed applications and machine learning algorithms. Basically, we extract, we analyze imagery data, satellite imagery, and as well from drone, and we extract all the information and we translate this information in a variable product. Where for this product, basically it always depends on the project. Obviously, all the projects are not the same. Sometimes we have to use private software, but in this case, we are explaining how to follow all this workflow using only open source. So basically, we have here all the toolboxes and programs that we have used. Sometimes some of them are optional, but if we follow all this workflow with these tools, we can produce the final map without problems. This is the workflow that we are going to follow. Obviously, we explain in groups. Basically, obviously, the first step is to select the imagery. Unlike terrestrial images, as we are trying to extract marine habitats, basically, obviously underwater, we need to take into consideration more parameters. For terrestrial images or terrestrial products, basically, we need to focus on, to have 100% coverage, the date of the images, color cover, that's all. But for this case, we need to pay attention on the water condition, on the water quality. So, for example, the waves, the sun grain, and as well the turbidity of the water. Basically, on the first image, we have two images. The left-hand side, it's a really clear water, no wind, no waves, so we can extract. We can see clearly the different coral or reef. For example, we can see patch reefs, the fringing reef, different habitats. However, obviously, if we have an image with waves, basically this provokes a lot of noise in our output. So basically, it's going to be harder to extract the final product. Similar with the sun grain and any sediment or turbidity in the water. Basically, we need to take into consideration all these parameters. Regarding the input, obviously, we need satellite imagery. In this case, I wanted to put the two options. Basically, we can as well produce the marine habitat map with open source imagery, in this case, Sentinel. But obviously, we can use as well, well, commercial satellite data. In this case, Airbus, could be Maxar. Obviously, on one hand, we have 50 centimeters, on the other hand, 10 meters. The number of habitats that we are going to produce are not going, I mean, using different images are not going to be similar, the same for obvious reasons. If we use 50 centimeter images, we can talk to extract maximum like 12, 14, 15 habitats. If we use Sentinel, we need to merge to group to have a general output, general classification, and probably we are talking about 7, 8 different habitats. But to have a general idea is really good. So once we have selected the image, we need to process the images. Obviously, it depends on the level of the image that we have corrected. If we download a Sentinel-2, sometimes, it's level 1, and obviously we need to improve that image, to process that image, to have a really good quality output. In that case, if we take a level 1 image, we need to also rectify the image, basically to reduce any distortion in the image, to use a digital elevation model. In this case, if we are using Sentinel-2, we can use SNAP software. Basically, this is a European Space Agency software that we can process any Sentinel imagery. As well, we can also rectify the image and correct, atmospheric correct, run an atmospheric correction, basically to remove any distortion that the atmosphere can provoke on our data. I have included here, the Snap software. Send2Core is a plugin into that software. But there is, if we are using commercial satellite, we can use Accorite. I don't know how it's pronounced, but it can accept. This is as well another open source plugin. It accepts commercial satellites like Pleiades or any other Maxar satellite. Sometimes, as I said at the beginning of the project, of the presentation, if sometimes we need to use a private software to process the image if we are using commercial satellite, because sometimes this don't or is not very good when we use 50 centimeters image. Continuing with the, for example, open source software for imagery processing, once we have correct the image, we need to pan-sharpen the image. That means we take the highest, spatial resolution from the panchromatic band and the highest spectral resolution from the panchromatic, from the multispectral image. So basically, we take the best of each, and we have a pan-sharpened image. Basically, we are improving both resolutions, the spectral and the spatial. This can be done in QGIS. Basically, there is a tool, pan-sharpening, and we select basically the two bands, the image, the panchromatic, and the different bands. And the output will be the pan-sharpened image. Once we have this image, we need to produce more information. We need to extract this information from the image, basically to extract, to identify the habitat from the image. The more information, the better. Basically, because the algorithm needs different information to differentiate what is X, what is Z, what is Y. So basically, in this case, we run different indices. All these indices can be done in QGIS as well. Obviously, with the raster calculator, we can add all the different formulas. In this case, we run NDWI, so basically a water mask. In this case, we can see we are focused on marine habitat, so we don't need to extract any terrestrial output. So the first thing is to differentiate between marine and terrestrial, and then all different indices, vegetation indices, and chlorophyll indices, etc. NDVI or SAVI can be used. Basically, the more the better. I added here as an optional bathymetry. Basically, it's a satellite derived bathymetry. It's not needed, but as I said, the more the better. Basically, if we have, well, in case that we have different habitats with similar spectral nature, for example, we have corals or different, like in a coral we can see a fringing reef, patch reef, different types of reef. But basically the spectral signature is the same, but it's only the difference is morphologic. Basically, depending on the size, the texture of that habitat, or even where that habitat is located. If it's beyond 10 meters depth or on shore, it could be one type or another type. Basically, yeah. I mean, there is an open source plugin. This can be used, I think, if I'm not wrong, in QGIS. Basically, it's a relative bathymetry. It's not, obviously, it's not real, but it takes into consideration, for example, a seagrass area. So all the seagrass has the same elevation. And then, obviously, we can have an idea about the depth of the area. For that, obviously, we need all the blue or green bands, optional the other bands. And then we need some information of the actual depth. It could be nautical charts, or, for example, sometimes the client provides this information. Now that we have extracted all this information, we can basically now we can start creating the training area to ingest to feed the model. Basically, we select the image and okay, 5 minutes. I have 5 minutes to finish. And yeah, so basically, okay, the team say, okay, this area is mangroves, for example, or this area is seagrass, this area is coral. Basically, we create this database, and then we add this information into the model. For the classification, we use a supervised classification. Basically, we are telling the algorithm, the model, what it needs to extract. And we follow a random forest classification algorithm. Basically, this means that it creates different trees when the model finds an area. Basically, they have 3 or 4 options. This could be mangrove. This could be seagrass. This could be sand or coral. And according to the different data that we have added in the previous step, the indices, the bathymetry, etc., the model selects one option. Basically, obviously, these are the parameters that we can include. Basically, the number of trees, how many trees we want that the model runs. Obviously, the more, the better, but obviously it takes more, longer to run. The method, obviously, we have 2 methods, the Gini and entropy. The recommendation is to test both. Basically, I mean, we are not going to find the best, the final output in the first attempt. Basically, it depends on the area, it depends on the image. Basically, it's just to try and error. The maximum depth of the individual trees, as I said, the deeper the tree, the more splits. So basically, if they have more options to select, they are going to run, and basically, obviously, the quality will be better, but it will take more resources and, more time. And then, obviously, the number of features to consider. So basically, if we are extracting only 4 features, it could be very quick. Like, okay, I have 4 options, or this. But if we are adding 20, obviously the model will take more time. And then as well, the percentage of training data. The training, for this first iteration is a draft version, because after this output, we need to select training data. This is not always possible. It depends on, if the client, or if we can go to the site to take this data, or we can use any previous web maps, etc. In this case, we use that first iteration to see, okay, what is here, if this mangrove or not, and we select different training and validation. Basically, we usually select 80% of the points for training to ingest the model, to improve the model, and 20% to validate the results. Then, once we have collected all this data, we run again the random forest, adding this information. And just for the final, the final steps of the classification, basically we need to post-process this final random forest output. In this case, obviously, the output is a raster, is not the final product, so we need to smooth the data and run some filters, obviously, because we will have some noise in the data. Then obviously we can use, for example, the SIF filter in QGIS. All these tools are found in, can be used in QGIS. Basically, next we need to clean all the data, the boundaries using merge, dissolve, as well to polygonize, convert the raster to vector, because from the satellite we have raster, but we need vector to add more attributes and more information. And then obviously we need to establish a minimum mapping unit. So for example, if we are using 50 centimeters image, basically if we have 50 centimeters polygons, that provokes a lot of noise. So the idea is to establish a minimum to merge with the adjacent area. And the final result, obviously, we run a final QA/QC. Some manual corrections is needed. Obviously, after all the automatic processing filters, we need to go to QGIS and select manually some areas. And then the final map is something like this. So, for example, obviously, this is using a 50 centimeters satellite image. In this case, I think we have 14 different classes, obviously from deep open ocean or water to intertidal mud with mangroves, fringing reef, patch reef, algal, hard ground, etc. So basically, using all this open software, we can get all this information for to analyze or even for development or some area, just to know what is happening in this area. I hope it's some time, and thank you very much.
Awesome, thanks, Javier. I think they're still setting lunch up, so we've got time for a few questions.